reflections. And there's 3 different reflections that you need to be able to manage. A reflection across an x-axis, a reflection across the y-axis, and a reflection across some reference line. If you are reflecting across an x-axis, what's going to happen here? Again, if you just imagine what you're looking at, so here's my x-axis right here. So if I took a point and I reflected it across the x-axis, here the x-coordinate stays the same, but the y-coordinate gets switched to its negative. So that allows you here to see the x-coordinate's going to stay the same, but it's going to give you the opposite y-coordinate. And now, what if you shifted or you reflected across the y-axis? Okay, so if I were to take a point, let's say starting again this point, and I reflect it across the y-axis, now the y-coordinate stays the same, but the new x is the opposite of the original. So I'm going to get a new opposite x, but my y is going to stay the same. Okay, and then if you are reflecting across a reference line, and it could be a horizontal one or a vertical line, what you're going to need to use is use the distance from that reference line. And I'll show what that means here in the example below. Okay, but let's take a look at a couple of these instances here. Okay, so the first problem asks us to reflect across the y-axis. Okay, I definitely encourage you to sketch at least one of the points to see what your rule is. Okay, so if you are reflecting across this y-axis, and you take this first point, -3, 6. Okay, so I'm just going to sketch that. And if I reflect across the y-axis right here, I'm going to see the y-coordinate stays the same, but I get the opposite x. Once I establish that one rule, I can now apply that rule to all the others. So I'm keeping the same y, so the same y here, the same y here, and I'm taking the opposite of the x's, so a -9 here and a +7 here. So if you establish the rule, again, it saves you from having to test every single one and go through all of the transformation rules. And now the last question that you're going to see on many of these types of problems is how does the area of the image after the transformation compare to the original? And because these are isometric transformations, there's no change in shape or size, so what do you think is going to happen with the area? They'll always stay the same. Okay, and so I include that even though it's somewhat redundant just to emphasize that fact. All right, so let's take a look at what happens here in this next question. We're reflecting across a given line. So it's not the x or y axis, but it's an actual line. The line is x equals 6. So what I'm going to do is I'm going to kind of sketch that in. So here's my line x equals 6. I don't have to label it to scale or anything, just a general rule. Okay, and I'm going to plot my point. I'm just going to plot my first point to see what happens here. So I'm going to plot -5, -1. So here's -5, -1. And if I reflect it across this x-axis, or I'm sorry, this vertical line here, x equals 6, what I'm going to do is I'm going to use the distance from that line. So this given point is 6 units to here plus another 5 units. So that's a total of 11 units away. And I'm going to use that to see what happens when I reflect it. Well, which coordinate's going to stay the same if my line of reflection is an x equals 6? The y stays the same, right? So I'm going to go ahead and fill all those in. I know my rule. I'm going to apply that rule to start with. And then when I find my new x has to be the same distance from my reference line as the original. So the original was 11 units. If I go 11 units to the right of x equals 6, what's my new x coordinate? 6 plus 11 is 17. Okay. So with D, the same idea. I'm going to go ahead and plot what I have. So 4, 6. So here's 4, 6. I'm going to look to see what distance is this point from my reference line. The x coordinate 4 is how far from 6? 2. So I need to move it another 2 units. What's 2 more units to the right of 6? 8, so that's my new x coordinate. And my final one, negative 6, 5. So when I look here, what's the total distance? So here's 6 units to here plus another 6 units to here, 12. So when I reflect that, it's another 12 units away from 6, which gives me 6 plus 12, or 18. Okay, there's my solution. The area, again, because this is an isometric transformation, is not going to change any between the two, the reflection and the original. And so that would be my solution. All right, so if I take my original, my line that I'm reflecting across is y equals negative 6. So I'm going to sketch that here. And if I just start with one of my points, I'll take t is negative 6, 3. Again, it doesn't have to be to scale, but you need to be able to see. When I reflect it across this line, which coordinate does not change? X's. So what I'm going to do is I'm going to go in first, and I'm going to plot, or I'm going to insert all of my X's, because I know my X's stay the same. Okay, and now when I test this first one, how far is this point from the line y equals negative 6? Well, it's 6 units up here plus another 3, so 9. So the reflected point is going to be 9 units from negative 6, which takes me to what? Negative 6 minus 9 is negative 15. So move to the next one, negative 4, negative 9. So here's negative 4, negative 9. Well, notice what happens here. So negative 4, negative 9 actually falls on the other side of this reference line. That's still okay. Okay, we just find what the distance is. From negative 9 to negative 6 is a total distance of 3. So I'm going to move up 3 more. And so what would that new point be? Negative 6 plus 3, so negative 3. And then finally, negative 7, negative 2. So here's my point. I find the total distance from negative 2 to negative 6 is 4. So if I move 4 more units down, I get to what? Negative 10. What's going to happen to my area in this transformation? Isometric, so it's going to stay the same. Where it's asking you to reflect across the x-axis. Again, you don't have to memorize the rules. You should be able to recreate it just one time and see what the rule states. So here's my x-axis. So I'm going to reflect across here. So if I take my first set of points, negative 1, 9, and I reflect it across the x-axis, okay, what coordinate stays the same? The x stays the same, so I'm just going to go through, fill in all my x's by copying what's there. And what I see is my y's are simply going to change the opposite. So I'm going to go through negative 9, negative 5, positive 8, negative 8, bless you. And that gives you your simplified